Hello and welcome to the 6th episode in our series where we create a 3D rendering engine from scratch. In this episode we will be doing nearplane clipping and culling of triangles that aren't visible to the camera, which should speed up our 3D rendering engine and get rid of some bugs that we currently have. Our end goal is to make something that looks like this. So we can move around and view our object from different angles, and our program will take an object file and a texture file and render something that looks like this. So last time we finished off with creating this bit of code which draws our triangle with its texture, and in this episode right over here we will be taking our triangle that's had all of its transformations applied and camera moved and then points projected. And then we're going to be running a series of checks. So is the triangle visible on the screen? So is all points visible on the screen? And if so, is the triangle behind the camera? And if it is, then we're going to cut it into either one or two triangles, depending on how it's placed. So that there's no part of the triangle behind the camera that causes weird bugs. All of the triangles and all of its points are always in front of the camera. So if a triangle has one point that is behind the camera, we need to create two separate triangles. And if it has 2 points behind the camera, we only need to create one new triangle and cut it along the near plane. So before we write this code, we're actually going to go up here and we're going to write a little helper, a little piece of code right over here that's going to take an edge that's going to take 2 points on our triangle, and it's going to cut it in half according to a nearplane. So we're going to write bracket vector 3 bracket vector 2 intersect plane bracket vector 3 inside vertex, outside vertex, vector 2 inside UV, vector 2 outside UV, and then float near plane. And so what this is going to do is this is going to take in one of our points and the other one of the points, so behind the camera, in front of the camera and behind the camera, and the UVs as well, because we also have to do the same for the UVs. And it's going to take the near plane and it's going to find the new point in between these 2 points that is along the near plane. So the near plane could be 0.5, for example. So it's going to take these 2 points and it's going to create a new point in between these points that's 0.5 away from the camera. And so now we're going to write float t equals bracket near plane minus inside vertex dot z divided by outside vertex dot z minus inside vertex dot z. And this is going to get the point that is in between these two vertices along the z. And then next we have to convert this into an actual world coordinates that we can use. And so here we're going to write vector 3 position equals inside vertex plus outside vertex minus inside vertex times by t. And we're going to write vector to uv equals, and we can just copy this and paste it here, but change this to uv and this to uv, and finally this to uv, and this will also get the uv. And then we can write return position uv, and that will just return these two. So we'll have the new point and its new uv coordinate that we can use. And so that's finished. We're going to go down here, and now we're going to start with the culling. So we're first going, before we go on to using what we just created to cut the camera, we're going to do another check that we can do before we get to that, which is to check if the triangle is even visible on the screen to begin with. So we're going to write if p1.x is smaller or equal to 0 and p2.x is smaller or equal to 0 and p3.x is smaller or equal to 0, or then we can copy all of this and duplicate it, but change this to greater, and then also change this to screen width. So if it's on the other side of the screen, and then we can duplicate this entire thing one more and change all of this to Y. And then we can also change all of this to screen height. So that way we're checking the height of the screen as well. And then over here, we can just write continue. And that is going to skip this little section here for each triangle. Because what we're doing is we're checking if the triangle is not on the screen at all, if the camera can't see it at all, we'll skip the entire triangle because each of the triangle's points are not on the screen. But if it is fully visible, we'll obviously render the whole thing as it is. And if part of it is visible, which is what we're going to check now, then we'll cut it into multiple parts. Well, if part of it is in front of the camera, that is. What we're going to do now is we're going to write int vertices behind Nearplane and make it 0. And so what we're going to do is we're going to count basically how much vertices are in front of the camera and behind. But before we do that, we're going to quickly define a new variable at the top, and we're going to call this Nearplane. So we can just put that right here. Public float Nearplane equals 0.5 for now. We can change that later. And then down here, we're going to write if v2b.z is smaller than the Nearplane, add 1. So we're actually going to do plus plus. And we're going to do the same for the rest of it. So v1 v1b, v2b, and v3b. And so this is going to count our vertice 1, is it behind? If it is, add 1, vertice 2 and vertice 3, and then we'll know how much is behind and how much is in front, which is what we'll do next. So here we're going to write if vertices behind Nearplane equals 3, then continue, because all of the vertices are behind the Nearplane, so we don't have to render the triangle. And then we're going to write if vertices behind Nearplane is equal to 2, or vertices behind Nearplane is equal to 1, then we're going to run this code. And so this code is going to split the triangle up into 1 or 2 more triangles and cut it along the Nearplane, because there are 1 or 2 vertices across the Nearplane, behind or in front. So now we need to split and organize the vertices with the UVs to keep them in pairs. So we're going to write list vector 3 vector 2 vertices equals new list vector 3 vector 2, and then here we're going to write bracket vb1 triangle dot item 4 vb2, so comma brackets v2b triangle dot item 5, and then v3b triangle dot item 6. And so what we're doing is we're creating a new list with a vector 3 and a vector 2 in a pair, and then we're putting into it vertice 1 with our UV1, vertice 2 with our UV2, and vertice 3 with our UV3. And so now we need to separate the vertices based off of inside and outside of the Nearplane. So we're going to write list vector 3 vertices vector 2 UV inside vertices equals vertices dot where v equal to or greater than v dot item 1 dot z, which is greater than or equal to Nearplane dot to list. And then we're going to do the same thing, but we're going to do outside vertices, and then we're just going to flip this around. And so what this is going to do is it's going to look through our vertices list, and it's going to check, and it's going to sort them by whether they're in front or behind of the Nearplane into 2 new lists. And so now we're going to split the triangles. So we need to work out if our if there's only 1 vertex inside or if there's 2. So we're going to write if inside vertices dot count is equal to 1. Run this, and if inside vertices dot count is equal to 2, then run this. And so what we're going to do now is we're going to write bracket vector 3 vertex vector 2 UV. I'm going to call this new vertex 1. It's going to be equal to intersect plane inside vertices 0 dot vertices outside vertices 0 dot vertices, and then we're going to copy this and duplicate it. Going to change this to UV and this to UV, and then Nearplane. And then we're going to copy this line and duplicate it, call this new vertex 2, and change this 0 to a 1 and this 0 to a 1. So what we're doing is we're creating two new vertices. Because only one point was inside, it means we only need to make one new triangle. So what we're going to do is we're going to make the two new vertices, keep the same one that was inside, but make two new vertices along the near plane with intersect plane, which we made earlier on. And then we'll add that to our list. So now we're going to add it to our triangles. So we're going to write mesh.triangles.add inside vertices 0 dot vertices new vertex 1 dot vertex and new vertex 2 dot vertex, and then we can copy this and duplicate it again and change all of this to UV. Now we'll also need to put this in brackets again, and that should add it. Now one problem we might have with this is this triangle is already in camera space and has had its transformation supplied, and so when we put it back in the list and it gets run, this gets run again, we're going to apply the camera and transformation again, which we don't want. So what we're going to do is we're going to put at the end of this true. And this is going to give us an error. We're going to go up here and we're going to write bool, and over here bool again, and down here we'll just make this false, because when as we're creating and adding triangles into this, we want these to have their transformations applied. It's only these triangles. And then over here we're going to write if triangle.item7. So if triangle.item7 is false, then run this, because it hasn't had its transformations applied yet. But if it is true, then we want to run this. Now one problem we'll have is that all of these say they don't exist, because if this doesn't run, because it's already had its transformations applied, then we're not going to have these variables. So what we're going to do is we're going to copy these two ones and paste them out here, and we're going to write in here triangle.item7 item 1, item 2, and item 3. And then in here, we're just going to get rid of this. Because the variable already exists, we're just changing this. Changing these. And so, what we're doing is we're creating these new variables that we already created. And we're setting them just to what the triangle is. So, for this case, if this is equal to true, then we're just making this equal this. But if it hadn't, if this wasn't true, so it is a brand new triangle, then we'll go over and apply its transformations anyway, so no change will happen. And that's that part. We can now go on to if two vertices are inside. So we can actually just copy this code and duplicate it down here. Because it's very similar, we're going to change this to a 1 and this to a 0. And do the same here. And then down here, we're going to duplicate this. And we're going to change a few things. So we're going to copy this. And paste this here. And paste this here as well. Change this to vertices. And make this a 1. And make this a 1 as well. And do the same here. And then down here, we're going to change this to a 2. And then this to a 1. And this to a 2. And this to a 1. And then we're going to change this to a 1 and also this to a 1. And this is going to create two new triangles. Add this to our triangle list. And yeah, that's it. And so we can do one last optimization. Before we do that, we're going to write continue down here. And we do this because we want to skip the triangle that we've just cut. And instead, we're going to render these two new triangles that we've made. Now for that last optimization, we're going to skip triangles that are facing away from the camera. So the camera's looking at the back of the triangle. Because we shouldn't see them or need to see them. So we're going to write f, and 2 brackets, and then you're going to write in here p2.x minus p1.x times p3.y minus p1.y minus p3.x minus p1.x times p2.y minus p1.y. And if this is smaller than 0 and triangle.item 7 is equal to false, we're going to continue. And so what this is doing here is this is just checking something called the winding order, which is the order of the vertices. So vertices 1, 2, and 3, that order. And we use this to determine which way the triangle is facing, and then if we're looking at the back or the front of the triangle. And we're skipping over item 7, which is true when we cut our triangle. Because unfortunately when we cut the triangle, it doesn't keep the winding order. So we just need to render these triangles, whether or not we're looking at the back or front. We just need to render them anyways. But all of the other triangles we can apply this optimization to. And now one problem that we're going to have with this currently is we can't actually modify or add anything to this while it's going through each of the triangles in the mesh. So we're going to have to create a new temporary triangles list. So we're going to copy this and go down here and paste this, changing this to temporary triangles. And another problem that we might have is when we create this temporary triangles list, we can copy this code here and then write temp triangles.add triangle. We're gonna add and combine all the meshes in the scene and their triangles into one big list, which means we can't actually really tell the difference between each mesh, each object. So we're gonna have to add something else at the end of this. We're gonna have to write mesh, and then do the same up here. Right, mesh. And then down here we can also add onto this mesh. And so this will allow our program to then be able to access what mesh we are trying to access. So here we can just write for int t equals 0. T is smaller than temp triangles count t++. And then inside here, because we don't have triangle anymore and we still have to use temp triangles, we're going to replace all of that with this. So we're going to go down here and replace everything, all the triangles, with this. Now for mesh, we just have to write .item8 at the end of it like this. And then do the same for mesh. I'll just go down here and also do mesh. And then at the ends of these, we also have to write comma this, our mesh again. So temp triangles item 8. And then up here, we're going to replace it, but just get rid of item 8. We just want the triangle again, not its mesh. And continue down here. And over here we'll write .item 8 again. Item 8 and item 8. And there's also a bracket here that shouldn't be there anymore. And that's it for this part. So it's going to create our new list, and it's going to fill it up with all the triangles in the scene, and then it's going to run the code that we've made already. And so now let's also go down here to this, and we need to change this to just temp triangles.add, because we're no longer adding to our item 8 our mesh all the way at the top here. We're not editing the mesh directly. We're going directly to our temporary list that we created, which gets reset each frame. And so we need to add to this. And so that should be it for this part. Now let's go up here, and before we do a test, there is one problem that we've had, which is with rotation. This X should actually be a Y, and this Y should be an X. That will fix that rotation. Just a quick little fix to that mistake. And another problem that we would have that we have is with rotating the camera. Currently we're using this code, which is made for rotating objects, and what ends up happening if we reuse this code to move the camera as well is because we're adding location after we're rotating, it means we'll rotate the world first and then we'll move forwards, whereas we should actually move first and then rotate the camera. So we're actually going to copy this code and we're going to duplicate it. We're going to name the second part apply camera transformations, and we're going to go in here and we're going to create 3 new variables: float x, which will be equal to vertex.x, float y, and float z. And we will use this instead. Down here, we can simply just return these last values. We don't need to add this anymore, as we'll add this in this part over here. So XYZ. Now up here we can just write plus location.x plus location.y and plus location.z. So we're adding the rotation first, and then instead of going directly to vertex.x, we'll use the new x float that we've created that has the location added already, so before. So we're going to replace all of the x with this, and then we'll do y, and then we'll do z. Now don't replace the rotation, that stays the same. So we have x, y, z, that's right. So now we're adding location before we're actually rotating. And then to use this, we'll just copy this name that we've made. We'll go down here, and where it says apply transformations, and then V1A, camera location and camera rotation, we'll just change the second part to apply camera transformations to use our new updated code. And this should work properly now for both rotating objects with our quick fix and with rotating the camera now. So we can give this a try. Down here we can enter negative 1.5f for float for the decimal, then 0.5f and 0.5f. Down here for the rotation, we'll enter 0.6f, and we'll give our program a run, and you'll see that we're in front of the car now. And then if we change this 0 to a 1, you'll see we're going to go into the car. And it looks a bit glitchy inside the car, but this is actually working exactly how we want it, because you can see that our code that we made down here to create new triangles and cut along the Nearplane is working. You can see that these triangles have been cut and along the Nearplane, and is working correctly. And we can actually see what triangles have been cut exactly if we close our program and put 2 slashes behind all of these lines and give this a run. You'll see that the triangles that were visible are no longer visible, and those were actually the triangles that we were creating, the new cut ones. So we'll bring them back just so we can see again, and there they are. So that's it for this episode. We have fixed 2 bugs in terms of rotation, object rotation and camera rotation. And we have also added new code that will cut our objects along the Nearplane and do a few more optimizations to make it run a lot faster when we have a lot more objects with more triangles in the scene. Next episode we will probably be doing multi-core, so adding multi-core support using multiple CPU cores to make it run even faster.